So today, lesson 3.2.2, we are continuing our study with similar shapes. And yesterday we learned a way for shortcuts proving similar triangles. And there are 3 ways, so let me quickly review that. So there are 3 similar triangle shortcuts. The first is angle-angle similarity. That means if you have 2 congruent angles in the triangles that are given, you know that they're instantly similar. The second was SAS similarity, and that is that if you have a given angle or an angle that's marked equal or that you can figure out is equal, and the 2 sides that make up that angle are proportional. So for S's, you have to check the zoom factors or the ratios to make sure that they're the same ratio. And then A just means it's an angle that's equivalent. So this, again, the A is in between the S's. So in the picture, it's the angle that is in between the 2 sides you're using to test the ratios. That's called side angle side. And the third one is the definition of dilation, which is what causes similar shapes. And that is called SSS, because when we dilate, we literally use a scale factor and we do it to all 3 sides. So all 3 sides have to have the same zoom factor or scale factor or ratio. So the first problem in the lesson is 359. They give you these 2 triangles pictured and they ask you if they're similar and they ask you to write it in a sentence. I'm not going to write it all out in a sentence, but let's analyze the 2 pictures. I noticed 2 angles here, 2 angles here. There are no sides and no sides. So I can tell you right now, the second and third shortcut are out of the option. So it has to be angle-angle. And then you can quickly see these are both 75, these are both 32. So they are similar, yes. And they're similar by angle-angle similarity because angle A is congruent to angle T and angle B is congruent to angle P. Those are your 2 equal angles. All right. It gives you Julio's flowchart. So Julio was asked the same question. And it gives you his flowchart. He organized his similarity conjecture that he decided into what they're calling a flowchart because there's arrows, so it kind of flows. His flowchart has that angle A is equal to measure of angle T. This is measure, that stands for the degree. Measure of angle A, 32, is equal to the measure of angle T. Yeah, we said that. These 2 are equal angles. So I said angle A was congruent to angle T. He's saying the measures are equal. Done. That's the same. Measure of angle B is equal to measure of angle P. Awesome. Yes, we said that too. And then after you have your 2 angles, he said that you could state that the 2 triangles are similar. Just a reminder on similarity statements. You must go in the same order for the triangles. So he did C to A to B. So that was no label to 32 to 75. So you have to go Q to 32, T to 75. So you have to go in the same order as what you named the first. And then he labeled that angle-angle. So his flowchart describes exactly what we talked about in A. I will tell you that if I was grading his flowchart, he would lose a couple points on his flowchart because for me, every single time you put something into a bubble, you have to have a reason after it. This is an example of a reason, but the shortcuts are only at the bottom with similarity statement. So the question is, how do you know the measures are equal? So this has a 32, that has a 32. I know you guys all know they're equal. It's the same number. So when it's in the picture at the beginning, we call that reason given. Because it's given to you. It's right there. It's in the picture. It was in the book. It's obvious they're the same. Same with B and P. B and P, it's in the picture. It's printed in the book. That's also called given. So for me, you have to have the bubble stating what you know in the picture and then how you know it. And in this case, it was just given to us. And then he already had the reason for the bottom. All right, so then 60. They give you 2 more triangles and they say, are they similar? So let's analyze them. So these, I know this doesn't have a tick mark, but I don't know why sometimes they do that and sometimes they don't. So just assume that means it's supposed to mean they're congruent. So right now I have an equal angle C and R because it's marked equal. And then we don't have another angle, but we have these side measures. So remember for S's in the shortcut, you have to check the ratios to make sure they're the same. So let's say 2 is the smallest out of these 2 sides. So 2 and 8 have to go together, correspond. And 3 and 12 are corresponding because they're the bigger sides and these are the smaller sides. So let's do the divisions in C. So 8 over 2 is equal to 4. And then 12 over 3 is also equal to 4. So the zoom factors are the same. And we know the angle in the middle of the sides is already marked equal. So yes, they are similar by SAS. And then Julio was starting his flow chart to organize. So this is already given to you in the book. 12 divided by 3 is 4. We already did that. 8 divided by 2 is 4. We did that. They need reasons. So he doesn't put reasons in the book. I require them. So how do we know that? We did a division. And what were we actually computing? You can call it ROCS, and that stands for ratio of corresponding sides. Sides. Or I'm okay with zoom factor, ZF for zoom factor, because that's what we're actually testing. Or scale factor, those of you who like scale factor, I'm fine with that. So pick whichever one you like and use it. You can use scale factor too. Same thing here. This bubble gets the same reason as that bubble because you're finding the ratio. So I'm going to put ROCS here. ROCS for ratio of corresponding sides. And then he didn't finish. So there's another bubble that has to get filled in. So we have the two sides right here. That stands for the two S's. We need the A in the middle. So let's name our angle. Angle C is congruent to angle R. We know that because it is given in the picture. It's marked in the picture, so that's called given for the reason. And then arrow down, because these are our side angle sides. And notice they're out of order. They don't go side, angle, side. That's okay. As long as you have the information stated in any order, you're good to go down here. So let's just name our triangles. And remember to be careful of order. So if I call this one CDF, there is only one way to order this guy. So I started with C, so I have to start with R. And I went C to D, so I went down the long. So R to T is down the long, and that means Q has to come last. And the reason for this is side, angle, side similarity. It was the shortcut side, angle, side. All right. I went back to yesterday's lesson just so you could see a couple more flowcharts before I have you practice them. So this is problem C from 51. We did not do it yesterday, but I wanted to show you. We had a triangle inside a triangle. So I think most of you can tell that this is just dilated to get the big one. So we know they're similar, but what shortcut proves they're similar? If you don't have any sides marked in the picture, you can't use any of the shortcuts with an S. So this has to be angle, angle. And I pause for a minute to let you think. The top angle M is used in the little triangle and it's used in the big triangle. So angle M is actually the second angle. So these two are marked, but that guy is the one that's hard to see. So there's our second angle. So I already did the flow chart. I just am going to show you so you can see it. Angle M is congruent to angle M because it's in both of the triangles. That property is actually called reflexive property. If you state something is equal to itself, reflexive property is what it is. I accept right now it's called same angle. I'm okay with that. Here's the other one, and I like to point this out because at point N, there are two different angles. There's one up here and then the one on the bottom. So you have to name with 3 letters, M, N, H. Same thing with S. I went ahead, actually you could call that one angle S, but I went ahead and named it with 3, M to S to L. That's how we name angles. And then this one is given because it was marked. And then I was careful with my order and I put angle, angle here because that's what we decided. All right, and then I also went through quickly, this is D from 51 from yesterday's. We didn't get to it. But if you look at the picture, there are no angles marked or no angles measures given. So you know angle, angle is out. So is SAS. So this has to be side, side, side. So if you look at the start of my flow chart, I started calculating the ratios. I did all 3. However, I did small side on this triangle to small side over here. That's how I matched them up, because they don't really look like they're similar. Over here I did big side, or the big side to biggest side and divided, and then I did middle to middle and divided. 5 is the ratio here, 3.6 and 4.6. They are not equal, which means instantly we do not have similar shapes. So you do not have to do a flow chart if you don't have similar shapes.